Hello, everyone. What I'm about to share with you today has the potential to completely change the way you think about muscles and strength training. When we look at physical activity through the lens of biochemistry and physiology, there is far more happening than meets the eye. You'll discover how training influences numerous systems in the body, extending both the length and the quality of our lives, while protecting us from many diseases. It's important to note that this video is built on clinical guidelines, systematic reviews, and meta-analyses. So there will be no myths or unverified claims here, and if you'd like to dive deeper into the topic and check the evidence yourself, you'll find links to all the studies in the description below. Lack of physical activity is associated with an increased risk of cardiovascular disease, diabetes, obesity, certain cancers, depression, and reduced bone strength. More broadly, physical inactivity is directly linked to a shorter overall lifespan. 33% of people worldwide die from cardiovascular disease. That's every third person. Paradoxically, the reasons behind this have been known for decades. 75 years ago, the longest and most influential epidemiological study in the history of medicine began, the Framingham Heart Study. It identified 7 major risk factors for cardiovascular disease, and physical activity is one of the key ones. At the same time, according to WHO statistics, 80% of adolescents and 30% of adults fail to meet even the minimum recommended level of activity. 150 minutes of aerobic exercise and 2 strength training sessions per week. And are those present in your life? Remember, that's only the minimum recommendation, averaged across the entire global population. But what if I told you that for the prevention of cardiovascular disease and even cancer, the minimum threshold might not be 150 minutes of cardio and 2 strength sessions per week, but just 6 minutes? It sounds surprising, but a study published in Nature Medicine showed that as little as 3 episodes of 1 to 2 minutes of intense physical activity per day can reduce the risk of death from cancer and cardiovascular disease by as much as 40%. That means just 3 to 6 minutes a day can already make a measurable difference. I intentionally used the word episodes, not sets, because participants in that study didn't perform trendy exercises. They didn't even train. These were simply moments of vigorous movement embedded in their daily routines, climbing several flights of stairs after work, playing energetically with their kids, doing active housework. Of course, this is not enough for a comprehensive approach to health, but it proves that you don't need to wait for the perfect moment when you finally have time. Add at least a small amount of intense physical activity today, and even that will pay significant dividends in the future. Let's move on. A study involving 650,000 people examined a benchmark of 150 minutes of moderate aerobic activity per week, or 75 minutes of vigorous activity. Participants were divided into 3 groups. The first group, which exercised less than the recommendation, reduced their risk of death from all causes by 20%. The second group, which increased activity to meet the recommendation, reduced that risk by 31%. And those who exceeded the recommendation achieved a 37% reduction in all-cause mortality risk. What does reduced risk of death from all causes actually mean? It's a metric commonly used in research that reflects the likelihood of dying from any reason: disease, accidents, falls, or unforeseen events. After all, anything can happen in life. When you train, eat well, and avoid harmful habits, you increase your overall chances of survival. In reality, we have very few medications that can meaningfully influence overall life expectancy. Physical activity, on the other hand, is essentially a free pill available to all of us. You'll often encounter claims online that strength training harms the heart, or at least provides little benefit. First, these claims lack scientific support. Second, we are talking about moderate muscle development and resistance training, not bodybuilding or professional-level sport. A large meta-analysis involving 250,000 participants showed that moderate strength training alone reduced the risk of cardiovascular disease by 17%. That is a substantial reduction, especially considering it reflects strength training by itself, without any additional interventions. When strength training is combined with aerobic exercise, however, we see a synergistic effect. The risk drops by 46%. In other words, the benefit nearly triples when we combine these two types of training rather than relying on aerobic exercise alone. Even the American Heart Association, one of the most authoritative organizations in the world, has included resistance training alongside aerobic exercise in its guidelines since 2007. Next, let's talk about oncology. Almost every family has been touched by cancer in some way. It is a devastating disease. Even when it is not fatal, it often leads to severe physical exhaustion, enormous financial strain, and major disruption to a person's life. Yet, the destructive power of cancer is disproportionate to the relatively small amount of effort required for its prevention. In another study, researchers analyzed daily physical activity data from 22,000 participants in the UK Biobank. Individuals who accumulated short bursts of activity totaling at least 3.5 minutes per day had an 18% lower risk of developing cancer. Those who did just 1 minute more reduced their risk by nearly half, 32%. These findings mirror what we saw with cardiovascular health. The same everyday activity episodes, such as playing with children or cleaning energetically. Even if you don't train at all, that level of movement is already beneficial. And naturally, the effects improve further when we begin to exercise intentionally. This is true even for people already diagnosed with cancer. Median survival among cancer patients who engaged in regular physical activity increased by 5 years compared with those who remained inactive. Resistance training in particular has been linked to a lower risk of kidney and colorectal cancers, as well as meaningful improvements in health markers among those already living with the disease. Muscle mass acts as a kind of buffer tissue, capable of absorbing part of the physiological burden imposed by cancer. A higher proportion of muscle relative to body weight provides an advantage through greater physiological resilience and larger metabolic reserves. These factors help the body better withstand both the catabolic stress of the tumor itself and the demands of treatment. Looking at all of this, I believe the debate about useless muscles should finally be put to rest. As we've seen, muscles are quite literally a shield against many diseases. Yet after the age of 30, muscle mass declines at a rate of 3 to 8% per decade, and this process gradually accelerates. This condition is known as sarcopenia and is characterized by the atrophy of muscle fibers and a reduction in the number of myofibrils. In practical terms, you are physically losing strength. And importantly, this is an irreversible process that awaits all of us. However, studies of regularly training male sprinters found no significant changes in the fiber composition of the quadriceps muscle over a 10-year period. Sprinting, in essence, closely resembles strength training. It heavily recruits fast-twitch muscle fibers, and sprinters spend nearly a third of their preparation time in the weight room. It's no coincidence that resistance training is recommended as a first-line therapy for combating sarcopenia. Its entire purpose is to deliberately stimulate and preserve muscle cells. Let's move on. 1 in 10 adults worldwide has diabetes. Since 2019, this number has increased by 16%. In the context of diabetes, the metabolic benefit of muscles is enormous. After a meal, about 80% of glucose is directed straight into muscle tissue because muscles play a key role in its utilization. Most cells require insulin to take up glucose. However, in muscles, this process can occur independently of insulin. In other words, during muscular activity, muscles consume glucose without insulin, bypassing it, and this is extremely beneficial. By using our muscles, we significantly increase glucose uptake, thereby lowering blood sugar levels. Muscles are also capable of reducing chronic inflammation, which is an additional factor in the development of diabetes, namely insulin resistance. In the vast majority of cases, insulin resistance is associated with excess body fat. An increase in adipose tissue reduces insulin sensitivity. As a result, the body produces more insulin, creating a vicious cycle that continues until the system begins to fail. To summarize, one of the most important risk factors for developing diabetes is obesity. Accordingly, by reducing fat mass and increasing muscle mass, this process is, to some extent, reversible. That is, type 2 diabetes can be treated. Modern clinical guidelines already include the concept of diabetes remission. There is a marker called glycated hemoglobin, the key indicator used to monitor diabetes, and generally, the lower it is, the better. A meta-analysis of 20 studies showed that resistance training significantly reduces its level. Moreover, the greater the increase in muscle strength, the greater the reduction in glycated hemoglobin. Another randomized controlled trial compared 3 groups. One performed resistance training, another aerobic training, and the third combined both. The resistance training group achieved better reductions in glycated hemoglobin than the aerobic group, and results comparable to the combined group. In this study, just 2 resistance training sessions per week over 4 months increased cellular insulin sensitivity by 46%. Now let's touch on the hormonal system and dispel a few myths. When people think about resistance training, the first thing that comes to mind is testosterone. Many figures in the fitness industry build a cult around it and monetize this kind of magical thinking because it's very convenient to attribute all responsibility and all problems solely to testosterone levels. Yes, resistance training can acutely increase testosterone. However, a large meta-analysis of 48 studies showed that testosterone rises immediately after training, but returns to baseline within about an hour. 2 other hormones, growth hormone and insulin-like growth factor, also show only short-term increases after exercise. In the long term, resistance training and lifting heavy weights do not significantly change baseline levels of these hormones. Of course, these hormones are related to training and muscle tissue in one way or another, but more than 95% of the noise around this topic in the information space is exaggerated. This is not a reason for disappointment. Hormonal regulation is simply multifactorial and complex. If resistance training influences testosterone at all, it is most likely through improving body composition. And here, the connection is much clearer. Muscle mass and fat tissue are key metabolic regulators acting in opposite directions. Muscles help maintain testosterone levels, while excess fat lowers them through several mechanisms. For example, adipose tissue produces pro-inflammatory cytokines, creating chronic inflammation. It aromatizes testosterone, converting it into estrogen, and it is often associated with elevated insulin levels, which can suppress gonadotropin secretion. Thus, excess weight triggers a chain reaction that gradually reduces testosterone levels in the body. So, it is more accurate to view resistance training not as a panacea, but as a powerful tool that helps regulate a healthy balance of muscle and fat, which in turn supports normal hormonal function despite many negative factors. If we draw an analogy between a human being and a machine, our musculoskeletal system is something like the suspension and chassis, providing structure, stability, and mobility for the entire body. And like any mechanical system, it inevitably wears out. Starting around the age of 30 to 35, bone breakdown begins to outpace bone formation, and bone mineral density declines each year. Resistance training is one of the few types of activity that can effectively strengthen bones. Some studies conclude that activities like cycling have virtually no effect on bone density. Meanwhile, a year of resistance training can increase bone density in men by up to 5%, which is a very large change for bone tissue. Strength exercises create optimal mechanical loading that stimulates bone cells to increase density while also strengthening ligaments and tendons. If problems have already appeared, resistance training can alleviate symptoms of osteoarthritis, osteoporosis, osteopenia, and other conditions. And of course, it reduces the risk of fractures in old age. In elderly individuals, bones regenerate poorly and heal slowly. A single fall at that age can dramatically affect quality of life. Imagine being 65 years old. Life seems to be continuing as normal, but you sustain a hip fracture. This often results in a bedridden lifestyle with no guarantee of full rehabilitation. Immobility at that age is extremely dangerous. The body's defenses decline sharply, and about 30% of elderly individuals die within a year after such a fracture. And now the most important point. Research shows a remarkable ability of bone tissue to retain acquired strength even after training stops. One study compared bone density in the throwing and non-throwing arms of baseball players. The dominant arm maintained higher bone density even long after the athletes had stopped throwing. What does this tell us? That training earlier in life is essential to build sufficient bone strength that will serve you for decades. Meta-analyses involving dozens of studies clearly show that physically active school children have significantly higher bone density. And of course, we cannot ignore another myth, that resistance training is harmful for growth. To date, there is no evidence showing that resistance training stops or even slows growth during adolescence. The idea of upgrading the immune system with supplements is very appealing, and many people today are almost obsessed with it. However, a randomized controlled trial published in JAMA that lasted more than a year and included 700 participants showed that daily multivitamin use did not reduce the frequency or severity of respiratory infections, even among the elderly. In some cases, isolated vitamin E supplementation actually worsened illness severity. So if anything truly improves immunity, it is, once again, physical activity. The J-shaped curve hypothesis, developed in the 1990s, links exercise intensity with infection risk. At the initial stages, risk decreases, and with moderate physical activity, illness rates drop significantly. Exercise supports immunity through multiple mechanisms, for example, by increasing the activity of NK cells and T cells. NK cells are our natural killers, playing a crucial role in destroying viral, bacterial, and even cancerous cells. T cells proliferate more actively in response to pathogens and are responsible for adaptive immunity. However, if training intensity continues to rise toward overtraining, infection risk increases sharply. So, moderation is essential. Children who exercise regularly recover faster, and adults with consistently high levels of physical activity become ill about 20% less often than those who remain inactive. In the next video, we will dive into the depths of the mind and psyche. Because every time you lift a dumbbell or perform a squat, you activate an enormous number of biochemical reactions that energize the brain, improve memory, attention, and learning ability, help prevent neurodegeneration, and enhance emotional well-being. Train with awareness, and see you next time.